Hi everyone, welcome to YourPedia. Today with me as a Professor Pramod Kumar in IIT Mandi campus. So we are here in lab. सर प्रमोद कुमार, तो सर बताइएगा हम कौन सी लैब में हैं और आपका ये जो सेटअप है थोड़ा सा बताइएगा इसके बारे में.
Thanks Jatin. So I am Dr. Pramod Kumar. I am Assistant Professor in School of Mechanical and Materials Engineering at IIT Mandi, and presently now we are standing in Interfacial Flows and Heat Transfer Lab. So in this lab actually we are having number of instruments related to experiments of interfacial flows. So one of the experimental equipment which is very important for phase change heat transfer studies of interfaces is actually a boiler. So typically if we see in case of thermal power plants, boilers are used for generation of the steam, and then that high pressure steam we expand over the turbine to produce electricity. So whatever the turbines, whatever the boilers we see in case of thermal power plants, these are basically high power, high steam rate and then very high wattage boilers, and particularly these are operated with the help of coal, where coal used as fuel to heat water and then produce the steam. Over here I am showing you a very mini version of such a boiler. So this is called as non-IBR boiler. So basically a boiler which is having its drum volume less than 24 liters of volume, that is called as non-IBR boiler. So IBR refers to Indian boiler regulation. So if any boiler is having its drum volume above than 24 liters, then actually it has to be registered as per Indian boiler regulations. But this particular boiler is of smaller capacity, so for this such standards are actually not needed. That's why we are calling it as a non-IBR boiler. Another important aspect of this boiler is that in case of say high capacity boilers, we are having coal as the fuel to heat water and then produce steam. But in this particular boiler we are having actually electric heater. So if you just go inside and if you see these two sides, so this is our typical boiler drum, and this boiler drum is having some insulation, and then here if you see, this is one heater and one heater is at the back side and two heaters are on that side of the boiler drum. So these four heaters basically each of these heater is having capacity of 9 kilowatt, and altogether this boiler is of 36 kilowatts capacity. And over here we can see these are the switches to operate each heater. So at a time I can individually on each of the heater, and I can also simultaneously keep on all four heaters or any set, say 2, 3 or 4 as per my requirement of the steam mass flow rate. Another important point is, so this boiler is having this pressure gauge over here which indicates how much is the pressure of the steam inside this boiler drum. So basically this boiler is having capacity of up to 5 bar pressures. So it means on an absolute scale it can give me outlet pressure of 6 bar. And now you can see in this boiler drum, so this is basically the inlet of water, and this inlet of water is connected to a pump. So this pump is connected to tank and it discharges the water inside this boiler drum. And on the back side of the boiler we are having actually exhaust port for the steam. And on the bottom of this we are having this particular port for draining the water. Say if we have completed our operation and now we don't want boiler drum to be filled with water, so we can take out the water once our experiment is actually over. Now this particular boiler is having two main important safety features. So the first is we have a pressure switch over here. So this pressure switch basically avoids any overpressure within the boiler drum. So in case if pressure goes beyond the set limit of 5 bar pressure, then this pressure switch will automatically switch off the heater. Another important point we have over here is PID controller. So basically this PID controller is another safety feature. So here we set some value of the temperature, and when our boiler drum temperature is greater than the set temperature, then also it switches off the heaters. So this is having actually all the safety features in it. This particular non-IBR boiler can provide us steam at supply mass flow rate of 50 kg per hour. So we can continuously get steam maximum at the rate of 50 kg per hour out of this. However, if we want to get the steam supply at lower flow rate, that also we can get actually by controlling the discharge valve settings. And this particular boiler we are using in our lab for producing the steam, because in one of our experiment actually we are studying the collapse dynamics of steam bubbles in underwater systems. So for that particular experimental setup we are actually taking the steam from this system, and we are also in process of designing some organic Rankine cycle based waste heat recovery systems, and in such systems also for our initial demonstration of the organic Rankine cycle we are using steam from this particular boiler, or sometimes even hot water from this particular boiler to heat our systems. So that's all about
Great, sir. Sir, as we enter in this room and as you said that कि अभी सेटअप पूरी तरह से नहीं हुआ है, तो क्या इक्विपमेंट्स हैं हमारे पास जो है अभी आप दिखा सकते हो अगर?
So we have actually plenty of equipment, but at the moment we are in process of fixing these setups. Okay. So maybe individual equipment wise we can see at the moment.
Okay, okay. So thank you, sir. आपने boilers के बारे में बताया. So thank you everyone.